I'll have, as Urban said, I have a few talks lined up for the coming days. So two today and one more with a colleague of mine tomorrow. The first one I want to kind of kick the whole thing with is a little bit of my experiences that I have had throughout the years when doing reviews of the projects and doing reviews of large projects, and also working on large projects myself. Mostly it's going to be reviews from Java projects, but I mean, that really can be applied to any kind of projects of any platform or any kind of thing, really. So I decided to call this talk as escaping developer nightmares, because, you know, we all have this kind of scary things that we want to escape, and we, you know, want to do some things to escape those. But in reality, it could have been called, there could have been a little bit more boring title for that thing, which would be something like a typical challenges in software development at a large scale. But I mean, let's keep it a bit more fun. So nightmares it is. Like I mentioned, I will be talking about the projects and the large projects, and I've been doing both sitting on the development side, also tech lead side of those large projects, but also I've been on the reviewer side. So companies would hire me to do reviews of their software to check if it's good enough, if they're doing the right things, if the architecture is okay, if the code looks good, if whoever is developing that is should have considered some other things that they can do in the future, and things like that, you know. And the projects in question, and they're quite large projects. So I would say at least 350,000 lines of code of Java. I mean, it's been 400. It's been some of them have been 500. So it's a lot of code. I mean, it's such a big project that back in the days before solid state disks were actually a thing, we even had to buy our own solid drives. Like our company that was developing that, we actually had to buy solid state drives for the computers for the customer that we used to develop, just to make things go a little bit faster, and you know, Maven builds and stuff like that. So that was before Maven 3 and multi-threaded builds and, you know, all those kind of fun things that came up. But anyway, so at least around 300,000 lines of code. Typically would be around, I don't know, 20 developers, more give or take. Large old projects, I mean, projects that's been alive for, I don't know, so let's say 10 years, or, well, give or take some years. I mean, it's several projects, so it's difficult to say like exact numbers, but this is the thing I'm kind of going to be talking about. And then I, while working with those and doing reviews of those, and, you know, all those kind of different aspects of the project, I have decided to kind of sit down and make this, what actually makes a project good, or what makes it bad in a way, right? So it depends on which side of you look, right? The half full, half empty glass kind of thing. So a few words about myself first. So my name is Rustam. I live and work here in Oslo, Norway, where I'm from right now with you. So I'm kind of streaming from there now. I work for a consultancy company called Computas. I've been doing it for quite some time now, and most of those experiences has been through that, but also from some previous jobs as well. I am one of the Google developer experts. I'm also called a GDE. I'm a GDE for clouds, and I am also one of the Java champions as well. So this is a very, very short, brief introduction, and you'll find me on Twitter and other social media, well, mostly on Twitter probably, and my handle is on the bottom of the slide, so you'll find it there as well. So let's go back to the topic. So a paradise, or, well, nightmare, right? So if you do everything right, everything's going to be fantastic and it's going to be a paradise. But if things go bad, you'll have a nightmare. But then I also, there are two aspects to this thing. So one of them is, how do you avoid that? But then I also want to give you some, because some of the things will be things that you've experienced, you've seen, and it won't be that much new. But I want to give you also some arguments to help convince others that this is a bad thing or this is a good thing, and to actually do that, because sometimes that might be also a very much bigger problem, because, well, we all know that doing thing X is a good thing, but then you have to convince your project manager if you have some, or you have to convince your customer, or whatever your situation is, right? So I'll try to give you some kind of arguments for that as well. Then we can do some probably chat about more about that if we have time, or if not, we can do it on through other channels, whatever that would be, a chat or a Twitter or whatever. So the moving parts, and this is kind of the things I ended up mapping, and this is probably not a very surprising thing, right? You have in the beginning, in the middle of the whole thing, you have this paradise, right? And what do you have? What kind of parts it consists of? Well, obviously there will be code, right? Because we're writing code. This is the thing that we're doing. And that code and developer platform would have its own small pieces that would be things like architecture, like tools, like libraries that we're using, all these kind of very known things. In addition to that, there is this part of all the tooling that helps us to maintain and run and make that code work and put it deployed, and all those kind of things. And then the third one would be the documentation, and that's kind of those three main pillars of a good project, which is, again, most likely not a surprising thing. And then over to a little bit more surprising thing. So I decided to have a little bit of a few helpers to do this talk, to explain things, to show you easily when it's a bad thing or it's a good thing. And those helpers I have a confession to make. I actually ended up drawing myself some time ago, and even though it doesn't look like it, probably looks like a kid at the age of 4 or something. So behold my fantastic helpers. So this is obviously it's a zombie. It's a bad thing, right? A very fantastic, awesome drawing of a zombie. And this is a gracious and fantastic unicorn. So again, yes, I did that myself. I'm not sure if I should say I'm sorry or it's a good thing, or, well, anyway, it's kind of attempt to make it a bit more colorful, this kind of talk. So I want to start to set a little bit of stage. I want to start to go a little bit, rewind time a little bit back. For me, it was slightly before my professional career in IT started. So mine started somewhere in early 2000s. So that was at least a few years before my time. But, I talked to some colleagues of mine that are a little bit, been having experience for a bit longer. And I was like, okay, look, tell me the most kind of scary thing that happened to you as a developer back then. And I just wanted to have this kind of the baseline of a nightmare kind of thing, right? So lots of things came up. I did write down a few of them, and I'll start with that, just to give you a little bit of idea of how bad things can be and how bad they were back then, and how hopefully how good they are now for you now. So first thing I want to talk about very briefly again, it's the waterfalls. So 90s were a time of waterfalls, and not the ones you see at the picture, but basically the as a software development thing. And they were beautiful waterfalls. I mean, they were fantastic looking, and sometimes very impressive, and very, with a really long the fall part of that. So you develop a lot, and then bam, and then you develop a lot, and then you kind of do next stage, and it's an interesting. It was an interesting time, right? So now we don't do that, right? Now we know it's a bad thing. Now we know it's kind of thing to avoid and everything. So okay. So what else did we do in 90s? Well, 90s we already had Java. It was it was first version of JDK came out in 96, right? So that's like mid 90s. It was still called Oak by then, but then it was renamed to Java a little bit later. So, but then what did we do in 90s, late 90s and something like that? Well, we did write Java, but we did write it in a Notepad and Emacs and Vim and all the other editors that might be there. There were no proper IDEs back then, or at least not as widely used and accepted, and things like that. So that was a bad thing, right? Actually, fun fact, Vim was released in 1991. So that was right there. Emacs was much older, but Vim was also quite a new thing back in the 90s. Emacs is from 70s, in case you wondered, but you probably know that. Another thing that we did was did this versioning thing. And the versioning thing we did was in a really, really odd way. I mean, there were no Gits and even Mercurials or any other things. Back then, we did things in virtual source safe. And I started, as I told you, I started working in 2000s, early 2000s, and I still had to kind of relate to virtual source safe. And I'm not talking about the source safe what it is now. I'm talking the old one where you have to like log files and check things and everything. And then we use things like CVS and things like that as well. You might remember, some of you, this talk is much more fun to do in public where you actually can see people, because then you'll see people nodding and they will be like, yeah, I remember. Oh my God, that was scary. So, well, you know, compared to what we have now, it's obviously a nightmare. Back then it was bleeding edge. But what else? Oh, we did compiling and building stuff. How did we do that? And I actually again experienced that some years later on older legacy projects. I actually had to relate to that. I had to work with that thing for some time. So what we did was to build class passes ourselves. We put them in bat files, and we used like Java Java C to compile things from the command line. And that was, you know, back then it was the way to do, but now it is a different story, right? So a bad thing. Issue tracking. Oh, that's fun. So I asked a colleague of mine, and I was like, "Look, what's the scariest thing that can happen to you?" And he was like, "Yeah, well, you know what? Back in the days before we had, I don't know, even Bugzillas and well, Jiras and all the other ones, we used to track bugs in Microsoft Access." And I was like, "Yeah, okay, that sucks, but I mean, why it's so scary? I mean, why you're selling it as the scary thing?" Well, he said, wait, I'm not done. We did put that thing, I mean, the Access database, which is the file database for Access that you cannot share, and you know everything that's your personal kind of thing. We put that thing on a shared network drive, and it was there. So what can possibly go wrong when at least two people open the same file that is not made to be shared or opened at the same time and try to do some kind of stuff? I mean, what can possibly go wrong there, right? So all those kind of nightmares, and let's go to this beautiful thing, right? They talk about the unicorns and rainbows and you know blue skies above us and above our code, and you know small elves singing songs while you compile your code and things, you know, whatever works for you, but you know, beautiful things. And I want to start with this tweet, which is kind of sets a little bit of the stage, right? You typically start a legacy code base, which is, I mean, let's be honest. I mean, most of the projects that out there will be some kind of legacy in them. Very seldom you get to start from scratch, and you know you have to cherish those moments. But you know, most of the times you'll be taking over a project that existed for some time. So then you're taking over that, and you try to figure out what's happening and what's going on. And it's really hard for us as humans to comprehend things that you know have been done by somebody else without and haven't been explained to us in a proper way. So you know, you try to run tests. Well, there are no tests, or they're not working, or they're broken, or they're even disabled, and you know, things like that. Okay, fine. What do we do? Well, I'll try to read specs. Well, the specs are not there, or they are there, but they're not updated, and that kind of sucks. Okay, fine. And then you try to write a fix, and well, you're eaten by an elderly code hack or a bug, or you know, anything, the troll that lives in a code base. You know, those I've actually seen those files. I mean, the things that they talk about, like on this comments like do not touch and things like that. I have seen that in the code. I've seen that not even once. So you know, all these kind of things. And then another friend of mine, I mean, we meet quite often at different conferences and everything. Michael, he did the same. He had kind of similar observation, and I was like, look, I'm going to put that in a presentation. So I did, and then yeah, well, you can read that yourself, right? But that's the thing, right? You think spending time and rethinking our faulty microservice deployments is more important, and why? And why nobody's going to see that? That's the backside of the whole thing, right? Why making things pretty? Because nobody's going to see it, and well, because how do you convince your project manager that writing things and things that I'm going to talk to about today is actually a good thing and it's not just a waste of time? So. Yeah, back to the moving parts, right? So this is the things that we're going to be talking about. And typically, all those things that I'm going to be talking about, they have had different, they've been used in different contexts for different things. So back in a few years back, it was very popular to talk about continuous anything. Now it's more of a commodity. Now it's everybody's doing that or kind of expected to do to some extent. So you have continuous integration, deployment, delivery, and all the CI/CD pipelines and everything, and automation. And with the cloud, it's much more normal thing to do and everything. So basically, all of those things that I'm going to be mentioning is part of this continuous whatever thing. And obviously it's a unicorn, or at least will make your life of being a unicorn, because you know, it will make your life much easier. And it's an important part here, you don't have to do all the parts at once. So if you do at least one, at least a little bit of one, you're already much better than you used to be. And that's really cool. But then this continuous things, continuous development, deployment, and all the other things. And now also, which is a very important part of DevOps and whatever ops, whatever that you put in the middle kind of culture. It's also very much a lot. It's a lot of the same kind of pieces there as well, right? And usually it's being sold to you as like a big rocket ship that will take you to the moon and back, and you know, it's going to be fantastic and safe and really, really cool. But as I told you, you don't have to do all that at the same time. You can actually do a little piece at a time, and it will still make your things better. And so, you know, the idea is that it will bring you this kind of, you know, the paradise thing. So here, like palms and you know, the sun and all the kind of things. And people, I mean, judging from the place we were at last year for this conference, this is kind of thing you have more or less here all the year round. We don't. I mean, we have snow and cold, and I mean, it's like for quite a few months a year. So we don't have that. So I put that as a paradise. That's kind of my little thing. Anyway, so those parts, right? If we just remove the palms and everything and go to a bit more of a thing. So let's talk about those different parts. What are they? So the first, the development part, right? The development part is the first thing I want to talk about usually is the code quality. So the code quality is an important part here, which is, and it also consists of different things, right? And the code part is an important thing here. What is, yeah, well, that's, what happened? Sorry about that. I have, sorry about that. I have a fantastic new keyboard that is very confusing sometimes. That's the kind of the geekness of the whole thing, right? All right, we're back. We should be back now. I hope it looks good. Sorry about the little jump. So there is arrows that I use, and then there is a page up and page down buttons right next to it. So what can possibly go wrong there? So the code quality. So the first thing I want to talk about the code quality is the code standard. And what I usually do when I do reviews of projects and things like that, I would actually ask people, hey, can you tell me that, I mean, do you have a code standard in your project? I mean, there are code standards that are general. There's a lot of people that the companies or even languages that they have own kind of standards for code standard, and or like, you know, advised things. But then each project should have their own. You can use that's been done for you by somebody else, or you can make your own or whatever, but just have something. So I usually ask the projects, I was like, do you have a code standard? Most of the times they would say, oh yeah, yeah, sure, we do. Yeah, yeah, of course we do. Everybody has that. And I was like, oh, cool, perfect. Do you follow that? And then they get a bit more insecure. So then they get like, yeah, I think so. I'll need to check, you know, and things like that. So this is one of the things. I mean, first, have a code standard. And the second thing, actually follow it. That's an important thing. It doesn't matter what kind of code standard you have it and just follow it and agree with each other that you're actually going to follow this kind of code standard between inside the team. So not just like everybody has their own code standard, then you don't have any. Another thing that is less important, I mean, because, I mean, code standard is quite an important thing because it will make your code easier to read and understand, and you'll get onboarding of the new people to the project easier, you know, all those kind of things. Another thing that is much less important, but also gives me a little bit of an idea of how project is doing, is to look at the files and the encoding of files, which is, you know, just what encoding the code base has. So you just check out all of them and just add the little scripts that would kind of troll through all the files and print all the possible encodings in a file. It does not, most of the cases will not break things. I mean, it will break if you have some special characters and they're not in ASCII, or, you know, they're not in the other encoding the other files use and everything. So I've seen things break, but it's usually it won't break things, but still. But then it gives me an important thing. It gives me an idea of whether people are using actually some kind of uniform tool for editing and actually having a proper code standard, or they're just using whatever they want. Some is using Emacs and somebody's using, I don't know, Eclipse IDE or whatever, you know, all these kind of things. Because, I mean, the thing is that, like I mentioned, if you have these things that don't have the letters that are not existing in the regular kind of the English alphabet of the English language, just like the standard one, things like, you know, this is typical, this is some Norwegian words with this extra letters, and then this is a Spanish, and then there is, you have some extra letters, and, you know, all those kind of things. So those, if you have those inside your code, that might break things. I mean, I've seen things break because of this. These letters and stuff like that. Another thing about the code quality, which is even less important, but still gives me an idea what, if you have some kind of agreement within team to use the specific tools or not, is actually mime type. So mime type doesn't really mean much. It's basically what file tells the other systems what it is and what's it supposed to be. It could be Java, it could be text, it could be, well, you know, all kind of things, XML, and, you know, it's just a little thing in a header of a file. But still, it gives me an idea. If I see a lot of different mime types combined with a lot of different encodings, I'll know that people are using different editors. That means they probably don't have their own kind of synchronized way of looking for bugs and looking for the other things, and, you know, all of those kind of things. It doesn't mean anything alone, most of the cases, so don't use it like categorically, but it will give you a little bit of a little drop of like, maybe you should look into that. So another thing is that I ask about usually is, do you do code reviews? And some of the horrible answers, like the horror and the nightmarish answers I've got, was like, no, we don't. And I was like, okay, but you've obviously considered that, right? Since you've heard about that, sounds like, anyway. And they were like, yeah, of course we know what it is, and we've considered that, but we don't. I was like, okay, why? Well, because we know each other so well. So, you know, we know how we write code. You finish each other's code lines, you know, almost. So, you know, we've been working for some time, and we're really put together and, you know, really cool and everything. And I was like, yeah, that's fantastic that you have an awesome team, but you still need to do code reviews, because this is not how well you know people. This is more about that we all people are kind of error prone and we do mistakes. Okay, so what else? Another thing is that we do is the development tools I want to talk about. So development tools is also an important part of the whole thing. And that is, one of them is obviously things like code versioning. So code versioning is an important part, because, well, you need to have some kind of tool that will do the versioning for you. And that's not only because about the historical thing, right? Just keeping track of your code. It's so many different aspects. So one of them is that you can delete code. It's okay to delete dead code, because in the worst case, it is in the code versioning. So you can actually find it and retrieve it from there if you have to, because I've seen also people commenting out lots and lots of code and keeping there just like in case they will need it later. Don't hoard code, just delete it. It's in the code versioning, right? If you're doing that. But then code versioning is also a very important thing from a totally different aspect as well, and that is branching. And do you have proper branching strategies? Do you have you thoughts of like, how do you do new features? How do you do feature branching, or you do something else? Or what is your main branch? Or what is your development branch? Or do you have a development branch, or you just push everything to main, and, you know, things like that, right? What else? So another thing that I usually would like to mention, and one would like you to kind of keep an eye on your code bases, is this things of complexity and how testable is that code. So if your code is very, very complex, it's very difficult and hard to understand and hard to read and hard to comprehend, it's going to be more errors there, or more chances to have errors there as well. And fortunately, there are tools to help us with that, right? You have some tools that do the static code analysis and all the other things. We'll talk about that in a bit. But, you know, there are tools. You don't have to just like have a feeling of, well, I don't like this code because it's complex, and then somebody else comes to us, no, but I like it, and then you have this thing going. So there are tools, and you can set some thresholds and things, and it will kind of do the complexities and everything. I mean, I've seen nested if loops going pretty much to the infinity and beyond, with just if, and then like, good luck figuring that out. Because if any of those things evaluate to whatever you don't want it to evaluate to, well, you know, have fun debugging that. And there are tools for that. So this is a screenshot, just a little bit of a screenshot from SonarQube. So the cloud version of there, where you can put all the open source projects. And they also show you, for example, for the test coverage. So this is an image of a test coverage. And you see, if you exclude all those that are at the zero, because you know that probably, hopefully, and probably most likely, they're using some kind of tool for testing that is not part of this code base, so it's not being detected by Sonar. So that's the zero. It's an extreme case. Just avoid that. But look how many projects that they are there in a little bit of test coverage. And again, by itself, this is not a metric. I've seen project managers and customers and everything measuring quality of their projects by the pure percentage of test coverage. Don't do that. This is not a good idea. If you measure developers by the percentage of the code coverage, they will make it work, but they will not make it work in a way that benefits you. They will just make the coverage go up, because we're people, we're trying to address what we're being measured on, and that's the only thing becomes the most important thing. So we might not even mean anything bad, but we'll just still solve it in the wrong way. So it's still a little bit of an information of how the project is doing, but don't use these numbers to measure the quality of it. So if your project manager, if your customer, or anybody do that, please explain that to them, that it's not actually the pure, the only way of telling if the project is good or bad, because you have test coverage over 90%. Well, it can be really, really bad tests with coverage over 90%. So yeah, and then so this is fun. I took a PMD project from quite some time ago, and I kept this slide because I thought it was quite fun. So PMD is a static code analysis tool, and it was on SonarQube. I just found it there, and then I looked at how many static errors or static issues they had on their own, and that was kind of fun thing. I mean, so the numbers are definitely not updated. Don't quote me on that, but it was kind of fun to see that, you know, this process of eating your own dog food kind of thing. That's it's you know, it's a bit fun. Some of the errors that were there, they're kind of obvious and they're not really an error, but some of them are. So when you do the static code analysis tools and everything, run them regularly and run them on something that is visible to the whole team. So when in the good old days when we didn't have a virus and we would sit together in open landscapes and everything, well, that probably can be discussed how good the open landscapes are, but let's not go there. Just assume that we're sitting there. Then you would have big screens that would kind of show this coverage, and you run it, for example, weekly, and it would go up and down, and you know, you'll see the arrows going up and down, and at some point it becomes a gamification thing, right? So all the developers really want to fix that little error, so the arrow will also point upwards or be green or whatever this week as well, and this drives this thing, right? So yeah, static code analysis tools we've talked, right? And the other thing that I probably should mention here is that you do static code analysis on the server, so you have a common set of rules, again, like with the code standard, but it's also possible to download those rules locally and run them locally before you commit, because then you will kind of avoid the double work kind of thing. So you don't have to do it twice and commit first and then, oh, I had this error, oh fine, I'll fix it and commit again. And so it's kind of working in the blind, that you don't want to do that. But then it's important thing not to modify those rules just locally. If you want to do some changes, agree with the rest of the team, put it on the server and download the rules from the server. Do the checks locally and everything, because if everybody has their own rules, again, it's exactly the same thing of the code standard. This is not a standard. This is not, you're not doing it right. It's going to fail anyway, because somebody has to win at some point, right? So another thing is that the plugins, right? So most of the tools that you're using Eclipse, IntelliJ, whatever, Emacs, any kind of tool that you're using, is probably there will be some kind of plugin that will do the things that you want. So they will do this, make sure that you have the static code analysis tools running locally before you commit, or you can do code standard things, and you know, all those things, linting, you know, all of that is mostly available. So make sure that you agree on what you're using, install the plugins for whatever you're using, and it's okay to use different tools, but just agree on that, and you know, all those kind of things. So another thing that I want to talk about is the third-party libraries. And third-party libraries is actually quite a fun thing, and it's a very important thing. So I'll use a little bit of time, and before jumping on to something else. So how many of you actually, it's another thing that's really fun to do in a public, in the room full of people, because I usually ask people, like, how many of you know all your third-party libraries, and you're aware of known issues and vulnerabilities in your third-party libraries? Well, usually it would be at best 2 or 3 hands in a room full of, I don't know, over 100 people or more even. So it will be like, well, probably in a bigger room, it will be like 3 hands maybe. But, you know, that's it. And most of us don't know that. And most of us don't really. Now we have all those things. If you put on the GitHub, there will be a dependabot or whatever that will kind of ping you and say, hey, I found a vulnerability in this thing. You should upgrade that and blah, blah, blah. But in the local projects, there are still, this is still an issue and still a big thing. And it's an important thing, right? Because it's a security thing and it's everything. Another thing that people don't think, and the thing that people think even less, and I've seen that, I've asked again people to raise their hands, and there will be even less hands. There will be probably even just hardly one hand, little kind of insecure going up. That's the thing about licenses. So how many of you actually know of what kind of licenses your third-party libraries are? I mean, I'm not really talking about money or no money, like paid, non-paid licenses. This is probably you have a control over. But then what license do you use? A library that is on the GPL, or it's an Apache license, or what is it? What kind of version it is? Is it compatible with all the other things? And, you know, all those kind of things is a really important thing, because at some point, if you use the wrong license on a wrong third-party library, it can just affect your own license. So for example, like, you know, like GPL, if you use a tool that is GPL, it just automatically makes all of your code GPL, which is really cool for open source and everything, but sometimes you don't want to share that. But at some point you just do it unintentionally, and that will be a little bit of a problem. So there is an article, I'll put a link up there about like why it's a good idea to audit licenses, and you can have a look at that. It's again, it's not a super fresh article, but these things don't change much. So this isn't still an important thing. That's why I kept it there. Another thing is that, well, obviously, if they are updated, maintained, and compatible, the libraries, the third-party libraries, because you can actually still use the libraries for the things. But if there are vulnerabilities that have been discovered and nobody patches that, then you still have a problem. And then there is another article or blog post from this time from Google, and you see it. It's again, it's relatively, I mean, it's a few years old, but it's exactly the same thing. I mean, it's just a little bit different errors now, where you have all those. They did run vulnerability checks for all the projects and all the things and that out there on the internet, and they found lots of different errors. So this is another article from SNCC, one of these companies that provide some kind of security checks and stuff. And it's a lot of vulnerabilities. And the idea is not to just tell you where they are, but just to tell you that they are there. And you should monitor your third-party libraries and check if there are something that has been discovered. Maybe you should disable something. Maybe you should update. If there is no update, maybe you should disable, and, you know, things like that. And well, again, more graphs to just give you a little bit of a kind of idea. The number of vulnerabilities are growing because we're getting better at we're developing more code, and we're also getting better at detecting them, hopefully. So, you know, there are more and more stuff. There's more links, so there's even more. And well, there is more. So just the idea to give you, like, I'm not going to go through all of that, but just, you know, I want to talk about some other things. I want to talk about the packaging, delivery, and deploy play, like the whole game of that. Is it automated? Is it manual? That's what I usually ask. And this is also an important thing to talk about, because very often it would be some kind of a hybrid of those two. And then whenever you do manual steps, it's very error prone, and it will bring a lot of problems. Because I worked on projects, really big projects, where I would have to do it. I would be the delivery responsible, and I would do some manual steps to deploy that, and I'll hand it over to ops, and they will do some manual steps to do that. And, you know, it's all that is just a problem waiting to happen, just to figure out when it's going to happen, because we're human, right? So we can just have a bad day one day, and some other day we do things a little bit different, and we try a new thing, and we think it's a good idea, and sometimes it's not. So, you know, all those kind of things. Another thing, an important thing here is also, how do you deploy things? Do you deploy in the same way, in exactly the same way to all the environments, or not? Because if you do it in the same way, you will actually well, first, you should have different environments. Please do. I mean, I've seen projects that don't, and this is scary. Seriously, I mean, I have seen projects testing things in prod, not in a good way. So don't do that. Have different environments, but then no matter how many you have, do it also the deployment and everything in the same way. Well, there are tools, there are things like that out there, but there are different tools. I'm not going to talk about that. Just pick something that helps you with all these kind of things and just use it. One more thing that I would like to mention is the architecture. So you have, I picked this picture for very philosophical reasons. You have like huge monoliths, like shooting up into the clouds, right? What kind of parallels that might be in IT world? I'm not sure. Well, it's probably you can figure that out. yourself. So the architecture of your application is also an important thing to look at, right? Do you have architecture that supports actually even a continuous deploy? And it's how does your application architecture look? How does your integration architecture look? And things like that. Code package structure, that's the fun thing. I mean, it's really fun thing. It was so fun that I actually even ended up writing a small bash scripts that would kind of pick all those things and visualize it in a simple way, or like show how things are working and everything. I mean, there are tools for that as well, but you know, sometimes you want to have something even simpler. So speaking of tools, I want to talk about, I mentioned already the environment things, right? Your sandbox, your test, your development, your production, pre-production, well, you know, all those kind of things. I mentioned this thing as well, right? Do you have same routines for deploy? Are your environments similar? I mean, they should be as similar as possible. It's very common to have a super beefy, like strong production servers with lots of RAM and CPUs and everything. And then you have tiny little things for testing. And then you will have errors in two different things, especially when it comes to performance. So that sucks. I have a few war stories from there, but I'll probably jump over those right now, but we can talk about that later, I guess. So are they similar? And if they're doing, you know, are you doing it the right way? Is your code rebuildable, code base or system, or your software, whatever you're doing, is it rebuildable with a simple script? Can you just, like, if everything burns down, can you just run one script and it just magically reappears after some time? This is the kind of thing that you can strive for. You don't really, probably you're not going to get there in one day, but at least strive for it. Try to automate and rebuild also infrastructure and all the other things with the code as soon as possible, and do it for all the environments again. What else? Well, are you running things in the same physical hardware? Because, you know, if you do it, it's a bad idea. I'll tell you again, very short. If you do performance testing on the test environment that using the same disks as production, you can think what's going to go wrong, right? Your production goes down. That's the spoiler alert. That happened. Monitoring. Are you monitoring environments, and are you monitoring all of them? And you're actually counting for errors. There is another fun article from Wired where they're talking about the moon landing and how they were counting for errors, and we should treat our code like that as well. Site reliability engineering and all those kind of things, and reviews of postmortems and things like that. They are very important things. Okay. Tools. And tools can be different things. So first of them, obvious one is an IDE. Another one is that you integrate your IDEs with the tools that I've talked about. That's okay. Another thing is that you can do check set commits, right? Whenever whoever commits something, they run some kind of tests, and if those fail, it kind of refuses to push the code into the code base. So that's another thing that you can do. You can do things like automating your tests and running them on all the levels. Maybe you don't do integration tests every commit. Maybe you do it at night, once nightly, and then give an error, or like send in messages to the people that have committed something throughout the day after or something, because those usually might take some time to run. But you know, your mileage might vary. Use build tool. There are many. Just pick one, go for it, use it. Use the build, like Maven, Gradle, whatever, to build your code. Don't do it yourself. Well, nobody probably does that. Hopefully nobody does that anymore. A bit more fun slides. So yeah, you know, this is how you choose a build thing. Docs. I want to talk one more quick thing before we're done with this thing. So tools for collaboration. So you use something, use a wiki, chat, Confluence, anything, but just collaborate and use one tool. Because I've been with customers where they asked, do you have this? And they said, yeah, we do. And I was like, which one? And they were like, well, we have two. Well, two don't work, because if you have two tools where you put all your documentation, which one do you actually update? The correct answer is probably none. And that sucks. Another thing is that the issue tracking. So again, my own drawings, but this looks more like a bug containment system. But system, but it's a bug tracking system. And the same thing, where do you track bugs? Do you have one system? I've been to a project, they had the same project that had 2 collaboration tools, like they had Confluence and SharePoint. They never updated either of them. I also asked them if they have bug tracking system. They said yes, and I was like, I knew that they said 2 for the other one. I was like, how many of that? And they said, well, 2. Because we use one and our contractors using the other ones, and we're just having a person sitting in between and syncing them manually. What can possibly go wrong there as well? And then I complained to a colleague of mine, and she was like, well, you know, that's not that bad. I'm working on a project right now where we have 3 different tools that are being synced manually. What can possibly go wrong there? Imagine having that job where you actually have to sync those manually as well, right? Yeah, so the moving parts are here that we talked about kind of briefly. I would love to talk more, and it's usually a lot of discussions there, but you know, we'll keep it short. And I also written a short kind of text version of the same thing on my blog about this tools that I've been using that I mentioned, and also this thing that I've been talking about. Things I've been talking about today, very short, very briefly, but you know, you can have a look at that. I'm done. This is where you can find me. You can find me on email, Twitter, or my blog that down there. So I'm slightly over my time, so I think I'll stop talking there, and we can do some Q&A and questions maybe offline in a chat or something like that. I don't know how that works, Urban. Thank you very much for having me, and see you a little bit later today for another talk on data pipelines, quite a bit later, well, a few hours later. And then there will be another talk on cloud and Java and things with a colleague of mine tomorrow. So, yeah.
Rustam, thank you for your talk. We are out of time for questions,
yeah.
But you said you have another talk, so if people have something, they can ask later on.
Sure.
Ping
me on Twitter. Yeah. Thank you very much.
Okay. Bye.
Bye-bye.